Welcome to Week 2 of Introduction to GIS. This week, we'll examine more details about GIS and mapping. GIS maps are made of layers of information. These layers are collections of similar geographic features and can represent any kind of geographic information, from elevation to addresses. The layering gives GIS its unique display and analysis properties. Look at the real world. We see that there are many different layering options. When we represent the real world in a GIS model, we're able to visualize these different feature groups as single layers, say looking at addresses by themselves, or as a whole, addresses in relation to elevation, roads, water features, and/or parcel boundaries. When we look at the world through GIS layers, it allows us to analyze information in a way that is different than analyzing any other kind of data. When the layers are drawn together, spatial trends and relationships often emerge. This allows GIS practitioners to gain insight about relevant characteristics of a location. Viewing the layers together creates a holistic representation of reality. This is truly where the axiom, "the sum is worth more than its parts," reigns true. In this example, we're looking at road proximity, geographically sensitive areas, visual exposure, and housing density. This kind of information would be very helpful in making a plan for future development. I don't know about you, but I would prefer it if my city planner looked at all of this data and didn't just use housing density to make development decisions. Spatial relationships are extremely important. In fact, we learn about spatial relationships even at a very young age. Here we take these same concepts that we learned when we were kids and apply them to our GIS data. A primary function of a GIS is to determine the spatial relationships between different items. The distance separating hazardous waste disposal sites to a hospital, school, or housing development is an example of a spatial relationship. You can also determine features that touch one another, lines that cross other lines, lines that cross other features, or features that overlap with other features. This information allows us to gain a lot of information about the space around us. Spatial relationships can be identified quickly and accurately using a spatial query. A GIS allows you to query features from one layer based on the relationship with features from another layer. For example, which towns have golf courses within their borders? If you were looking at a paper map, you would probably have to count the number of golf courses within that particular boundary. While that works, there is a possibility of human error. Not to mention, it can be very time-consuming. A GIS also allows you to query records based on aspatial data. As we learned last week, aspatial data is data that does not have a geographic reference and cannot be mapped by itself. Aspatial data queries are the simplest form of analysis, allowing you to extract patterns and meaning from your data based on certain characteristics. The query usually follows the form of a question. Select from the layer where. For example, select all the states that have a population density greater than 75. The lab exercises throughout this course will offer plenty of opportunity for you to learn more about both spatial and attribute or aspatial queries.